In the ever-evolving realm of cloud computing, security stands as a paramount concern for businesses of all sizes. As organizations increasingly embrace Amazon Web Services, or AWS, for their cloud infrastructure needs, ensuring the security of their valuable data and resources becomes paramount. This is where AWS Identity and Access Management, or IAM, takes center stage, acting as the gatekeeper to your AWS environment. At its core, IAM is a robust service that empowers you to manage access to your AWS resources with precision and granularity. It provides a centralized platform to control who can access what, safeguarding your data and applications from unauthorized access. With IAM, you can create and manage users, groups, and roles, granting them specific permissions to interact with your AWS resources. Imagine IAM as a digital security guard, diligently verifying the credentials of anyone attempting to enter your AWS environment. Just as a security guard checks IDs and grants access based on predefined rules, IAM ensures that only authorized individuals and services can interact with your cloud resources. Whether you are a small startup or a large enterprise, IAM is an indispensable tool for maintaining a secure and well-managed AWS environment. By understanding and effectively utilizing IAM, you can significantly reduce the risk of unauthorized access, data breaches, and other security threats. IAM is not merely an optional feature, but rather a fundamental pillar of security in the AWS ecosystem. Its significance stems from the fact that it provides a centralized and granular approach to access control, enabling you to enforce the principle of least privilege effectively. The principle of least privilege dictates that users and services should be granted only the permissions they need to perform their designated tasks, and nothing more. By adhering to this principle, you minimize the potential attack surface and mitigate the impact of security breaches. IAM empowers you to create a clear separation of duties, ensuring that no single individual or entity has excessive privileges that could compromise the security of your AWS environment. This granular control over access permissions enhances accountability and reduces the risk of accidental or malicious actions. Moreover, IAM integrates seamlessly with other AWS services, providing a consistent and unified security model across your entire cloud infrastructure. Whether you are configuring access to Amazon S3 buckets, Amazon EC2 instances, or any other AWS service, IAM serves as the central authority for managing permissions and ensuring that your resources are protected. When you create an AWS account, you're automatically assigned a root user. This root user is the master key to your entire AWS environment, possessing unrestricted access to all your resources and services. While the root user is essential for initial setup and certain account-level operations, it is crucial to understand that using it for day-to-day tasks poses significant security risks. The root user's unparalleled access makes it a prime target for attackers. If the credentials of your root user are compromised, the security of your entire AWS environment is at stake. To mitigate this risk, AWS strongly recommends that you secure your root user account and use it only for specific administrative tasks. Instead of using the root user for regular activities, it is best practice to create individual IAM users for each person or application that requires access to your AWS resources. By assigning specific permissions to each IAM user, you can limit their access to only the resources they need to perform their job functions. Remember, the root user is like a master key that should be kept safe and used sparingly. By following AWS best practices and limiting the use of the root user, you can significantly enhance the security of your AWS environment. Creating IAM users and groups is a fundamental step in establishing secure access control within your AWS environment. IAM users represent individuals or applications that require access to your AWS resources, while IAM groups provide a convenient way to manage permissions for multiple users simultaneously. To create an IAM user, you can navigate to the IAM console and provide a username and choose the type of access key you want to generate. You can then assign permissions to the user by attaching IAM policies, which define the specific actions that the user is allowed to perform on AWS resources. IAM groups simplify the process of managing permissions for multiple users. By creating a group and assigning policies to it, you can effectively grant the same permissions to all users who are members of that group. This eliminates the need to manage permissions for each user individually, saving time and reducing the likelihood of errors. When creating IAM users and groups, it is essential to adhere to the principle of least privilege. Grant only the permissions that are absolutely necessary for users to perform their tasks, and regularly review and revoke unnecessary permissions to minimize the potential attack surface. Section 5. IAM Policies, the foundation of access control. IAM policies are the backbone of access control in AWS, defining the specific actions that users, groups, and roles are allowed or denied to perform on AWS resources. These policies are written in JSON format and provide a structured way to specify permissions with granularity. An IAM policy consists of one or more statements, each of which outlines the permissions being granted or denied. Each statement includes elements such as the actions being allowed or denied, the resources those actions apply to, and any conditions that must be met for the statement to be effective. AWS provides a wide range of predefined managed policies that cover common use cases, making it easy to get started with IAM. You can also create custom policies to meet your specific security requirements. When configuring IAM policies, it is crucial to follow best practices to ensure that your policies are secure and effective. Start with a deny-all approach, explicitly allowing only the necessary actions. Use policy variables to make your policies more flexible and reusable. Regularly review and update your policies to align with changes in your environment or security requirements. Section 6. IAM Security Best Practices for Enhanced Protection. While IAM provides a robust framework for access control in AWS, it is essential to follow security best practices to further strengthen the security of your AWS environment. By implementing these practices, you can mitigate risks and enhance the overall protection of your valuable data and resources. One crucial best practice is to enforce strong password policies for all IAM users. Require users to create complex passwords that meet specific length and complexity requirements. Regularly rotate passwords to reduce the risk of unauthorized access. Enable multi-factor authentication, or MFA, for all IAM users, especially those with privileged access. MFA adds an extra layer of security by requiring users to provide a second form of authentication, such as a one-time password from an authentication app in addition to their password. Regularly review and revoke unnecessary IAM credentials. If a user no longer requires access to a particular resource or service, revoke their permissions to minimize the potential attack surface. Implement security auditing and monitoring to track changes to your IAM configuration and detect any suspicious activity. Section 7. Accessing AWS services using IAM credentials. Once you have configured IAM users and policies, you can access AWS services using your IAM credentials. AWS provides several ways to access its services, each requiring you to provide your IAM credentials to authenticate your requests. The AWS Management Console is a web-based interface that allows you to interact with AWS services. To access the console, you need to sign in with your IAM username and password. You can then navigate through the console to access and manage various AWS services. The AWS Command Line Interface, or CLI, is a powerful tool that enables you to interact with AWS services using commands in a terminal or command prompt. To use the CLI, you need to configure it with your IAM Access Key ID and Secret Access Key. The AWS Software Development Kits, or SDKs, are libraries that allow you to interact with AWS services programmatically from your applications. To use an SDK, you need to configure it with your IAM credentials, allowing your application to make authenticated requests to AWS services. Section 8, AWS Cloud Shell, your gateway to the cloud. AWS Cloud Shell is a browser-based shell that provides you with pre-authenticated access to AWS services. It is a convenient and secure way to manage your AWS resources without the need to install or configure any software on your local machine. Cloud Shell comes pre-configured with the AWS CLI, SDKs, and other tools, making it easy to start working with AWS services. You can access Cloud Shell from the AWS Management Console, and it provides a consistent experience across all regions and devices. With Cloud Shell, you can quickly run commands, test scripts, and manage your AWS resources from anywhere with an internet connection. It is an ideal tool for developers, system administrators, and anyone who needs to interact with AWS services on the go. Cloud Shell is a free service, and you only pay for the AWS resources that you use within the shell. It is a valuable addition to your AWS toolkit, providing a convenient and secure way to manage your cloud infrastructure. Section 9, IAM roles for secure service-to-service communication. In a complex cloud environment, you often need to enable communication between different AWS services. For instance, you might have an application running on an Amazon EC2 instance that needs to access data stored in an Amazon S3 bucket. To facilitate secure communication between services, AWS provides IAM roles. An IAM role is an IAM identity that you can assign to an AWS service, such as EC2, to grant it specific permissions to access other AWS services or resources. When you create an IAM role, you define the permissions that the role will have. You can then assign the role to an AWS service, such as an EC2 instance. The EC2 instance can then assume the role to gain the permissions defined in the role, allowing it to access other AWS services securely. IAM roles eliminate the need to embed long-term security credentials, such as access keys, within your applications or configurations. Instead, the AWS service assumes the role at runtime, obtaining temporary security credentials that are valid for a limited time. Section 10, IAM Security Tools and Best Practices, a recap. In conclusion, AWS Identity and Access Management, or IAM, is an indispensable service for maintaining a secure and well-managed AWS environment. By understanding and implementing IAM best practices, you can significantly reduce the risk of unauthorized access, data breaches, and other security threats. Remember to secure your root user account, create individual IAM users and groups, and adhere to the principle of least privilege. Use IAM policies to define granular permissions for your users and services, and enforce strong password policies and multi-factor authentication, or MFA, for enhanced protection. Take advantage of IAM security tools, such as the IAM Credential Report and the IAM Access Advisor, to gain visibility into your IAM configuration and identify potential security issues. Regularly review and revoke unnecessary IAM credentials and implement security auditing and monitoring to track changes to your IAM configuration and detect any suspicious activity. By embracing IAM as an integral part of your AWS security strategy, you can confidently leverage the power of the cloud while safeguarding your valuable data and resources.